All right, so now we know how to name type 1 binary compounds. Now we're going to talk about type 2 binary compounds. And remember, type 2 binary compounds are still a metal and a nonmetal, but the difference is that metal comes from one of those transition metals or a post-transition metal or something like that, right? One of these guys in here, one of these guys down here, because they can have multiple charges. Iron can have two different charges. Sometimes iron is 2 plus, sometimes iron is 3 plus. Okay? Now, here's the thing. So what? Who cares? Well, I care. And so does everybody else. Whoever does anything about chemistry. And even people who don't, because they care because, different types of iron are different and they react differently. And so you should care. All right. Anyway, because it's iron 2 plus and 3 plus, well, just saying iron chloride would have two different meanings. You could talk about iron chloride being FeCl2, or you could talk about iron chloride being FeCl3. Well, you can't have the same name that means two different things. All right? That's a good way to be dead. All right? So, we have to be a little bit more specific with type 2 compounds because we don't know the charge. So what we need to do is we need to have a way of indicating the charge on the cation in the name. And the way that we do that is we use Roman numerals. We use Roman numerals to indicate the charge on the cation. The charge. The charge on the cation. The charge on the cation. The charge on the cation. Did I say the charge on the cation? Yes, I did. Because I mean the charge on the cation. The Roman numeral indicates the charge on the cation. Guess why I say that so many times? Because somebody's going to do it wrong and put a Roman numeral that's not the charge. Anyway, the Roman numeral indicates the charge on the cation. So if iron is that Fe2 plus ion, then we call it an iron 2 ion. If iron is Fe3 plus, then we call it an iron 3 ion. Well, how do we know which ion we have? Okay, well, remember, a compound is always neutral. In other words, a compound always has a 0 net charge, right? So, what we have to do to figure out the charge on the cation is look at what it's bonded to. For instance, okay, FeCl2. Chlorine, if we look at chlorine, is a halogen, and so it has a -1 charge, right? And we see here that there are two of them, right? There's only one iron. So what we can do is we can set up an algebraic expression for this, all right, that says this. One iron that has a charge of X. You could call it whatever you want. I choose X because X is kind of always the unknown thing, right? So we have one iron ion that has a charge of X. We have two chloride ions that have a charge of -1. Okay? So what we can do then, and then we know that the net charge, the overall charge, is 0. Right? So we can solve this for X. X minus 2 equals 0, X equals 2. And therefore, we know that iron has a 2 plus charge, because that's what we just solved for, was the positive charge of iron. Okay, and so we would call it iron 2. Okay, now, some of you are already thinking, ooh, how can I find a shortcut to get around this? Don't do it. Okay? Don't try to find shortcuts. Learn it first before you try to find shortcuts. All right? So, what's the charge and name of a gold ion in the compound Au2O3? All right? Well, we have two gold ions. We don't know the charge of it, so it's X. We have three oxide ions, which have a charge of 2-. And we know that they have to total up to 0. So to solve algebraically. 2x minus 6 equals 0. 0. 2x equals 6. X equals 3. So the charge on that gold ion is 3 plus. Okay? And so we know that the name of that gold ion is gold 3, Roman numeral 3. Again, Roman numeral tells you the charge. Note that the Roman numeral does not tell you how many gold ions there are. It tells you the charge. So how do we name type 2 binary compounds? Well, we do it the same way. You write the cation first, you write the anion second. And then the only difference is the cation, the name of the cation, has a Roman numeral on it to tell you the charge, not the number of cations. Please listen to me. Okay? And then you write the root of the anion, and it ends with IDE, because it's a simple anion. Okay? So, let's take a look at a couple of them here. COCl3. All right? We got cobalt, we got chloride. Chloride has a -1 charge. So, and we have 1 cobalt. So, 1 cobalt, 3 chlorides with a -1 charge equals 0. X minus 3 equals 0. X equals 3. So the charge on that cobalt ion is 3 plus. Okay? And so we call it cobalt 3 chloride. Okay? SnBr4. Right? We have 1 tin ion. We have 4 bromides, which again is -1. It's another halogen. Okay, so plus 4 -1 charges equals 0. X minus 4 equals 0. X equals 4. And so we call that tin 4 bromide. Okay. Let's skip over and look at this last one here. Okay, for those of you who are trying to figure out patterns and things and not doing the algebra, don't. Okay, look. You got Pb, lead, you got sulfur, sulfide. Okay, sulfide, 2 minus. So we got 1 lead, 1 sulfide, 2 minus, equals 0. X minus 2 equals 0. X equals 2. Okay, so the name of that compound is lead 2 sulfide. Notice there is not a subscript of 2 anywhere in that compound. Okay, you can't look at the subscripts to figure out the Roman numeral. You have to look at charges. Have to. All right? Now, let's go the other way. The other way should be simple because you've already done it. Cobalt 2 chloride. Again, write the symbol of the cation with its charge, anion with its charge, switch them. Okay, nice thing is cobalt. Cobalt. That can have multiple charges. I wonder what the charge is. Ooh, if only there was something in the name that told me the charge. Oh wait, there is. I kind of got off a little bit there, didn't I? I guess I should look at what I'm drawing. So anyway, cobalt 2 has a 2 plus charge. Chloride, again, halogen, has a -1 charge. Switch them, and you get a formula of COCl2. Okay. Titanium 4 oxide, titanium, Ti, has a charge of 4 plus because it is titanium 4 oxide, charge of 2 minus. Switch them, We get Ti2O4, 2 and 4 reduce, right? And so you're left with TiO2. Okay? Lead 2 nitride, Pb2 plus, N3 minus, again, nitride. Switch them, Pb3N2. So now you got your type 2 binary compounds. Okay? In the next lesson, we'll talk about how to name type 3 binary compounds.